Hello everyone, so welcome back to my channel. In this video we will discuss about that today's problem of the day, that's name is minimum operations. Okay, so let us discuss about that problem statement. So you have given a number n, you have to find the minimum number of operations required to reach n starting from 0. Means of that, you have given us a number which is n, and you have to be perform some operation, so you have to be to reach the the particular number which is called n, and you have to be starting from 0. Okay, so you have available two operations right now. First one is that double the number, and second one is that add 1 to this number. Okay, I hope it would be clear to you that what does the problem statement saying. Now let us discuss about that problem example. Okay, so you have given a example which is n is equal to 8. So you have to be uh, performs those operation, and minimum number of operation required to reach that n. How could you solve this? You have to be starting from 0. First of all, you will starting from 0, and you will declare as a count variable which is equal to 0. Okay, which is equal to 0. So how you can solve it? You will simply add the 1 to this value, so our value would be updated by 1. Okay, so now our count value would be also increasing by 1. I hope it would be clear to you. Now again we will multiply by 2 of this current number. I hope it will be clear to you, so that the resultant value is equal to 2, and our count would be updated. I hope it would be clear to you. Now how you can, again we will simply multiply by 2, so we have to be getting 4, and count would be updated by. Now we will multiply by 2, so we have to be simply get this number 8. I hope it would be clear to you. Okay, so this is our value 8. So this is a minimum number of operation required is 4. So this is our answer. I hope it will be clear to you that what is the problem intuition. Now let us discuss about that another example. When n is equal to 7, so how you can perform? Again you will simply move on to the 0, and count would be initialized by 0. I hope it would be clear to you. This is a 0. Again, the base problem, the first operation should be always add 1, so the value would be 1, and count would be increased by 1. Now again we will add by 1, so that value would be updated by 2, and the count would be updated by 2. I hope it will be clear to you. Now again we will add by 1, so this would be value 3, and count would be increasing by. I hope it would be clear to you. Now we have to be do that multiply by 2, so we will simply getting the value 6, and count would be updated by 4. Okay, now again when we will add by 1, so we will get 6, 6 and count would be updated by 4. Okay, now again when we will add by 1, So the value would be 7, and this is our required solution, required value of n, and we will have to be get the count, which is our resultant answer. Only this only this is the way we can get this minimum number of operation required to 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 reach this value. I hope it will be clear to you. Now let us discuss about that value of n. But in this code, in this explanation of this code, where we have to be required some variable count, which is a constant space count, and we will make us some loop, while loop, which is always greater than n is always greater than 0. Okay, this is the coding approach. Now if the value is divisible by n, divisible by 2, so what we will do, we will simply half of this number, elsewise if it is not divisible by 2, we will simply decrement by 1. I hope it would be clear to you. At the end, and each and every time, we will getting some value count. But this code having a time complexity should be order of n. Okay, okay. Now we can also solve this problem by the help of recursion. By the help of recursion. Now how we can solve it? Suppose of that I will have to generate some function, which is function we have to be n. Suppose of that if this value is divisible by n, divide by 2, divide by 2. Okay, so what we will do, we will decrement by n by 2 and add our count. Okay, now in this case we don't have to be required count variable, generate a count variable. Elsewise we will, what we will do, we will increment the count 1, and the function would be decrement, the function value would be decrement by 1. Okay, and each and every time we have to be getting the 1, and our base case should be for this recursion, when when n would be equal to 1, so we will simply return 1. I hope it would be clear to you, but I am just dry run this approach, dry, dry run this case, so how you can solve it. Okay, first of all, just like just I'm just giving some example, which is n is equal to 10, n is equal to 10. Suppose of that n is equal to 10. Okay, so so how you can solve it? Suppose of that f of 10, because f of n is equal to f of 10. Okay, now the value is divisible by 2. Yes, it is divisible by 2. What we will do, we will increment the count 1, increment the value of 1, and divide this value by 2. Okay, so 10 divided by 2, so their quotient should be equal to 5. I hope it would be clear to you. So then it would be 5. Okay, now what we will do, we will this value is not divisible by 2. So what we will do, we will simply increment by 1, and f of value should f of value and the function would be decrement by 1. Okay, now again this value f of 4, the n is divisible by 2. So what we will do, we will simply increment by 1 by this function and divisible by 2. Okay, so 4 divided by 2, now 4 divided by 2 is equal to 2. I hope it will be clear to you. So this value is came here. I hope it would be clear. Okay, now again we have to be getting this value is also dividing by 2. So when the 2 will be divided by 2, so we have to be getting 1, and, return the value 1. When this value would be returned 1, so 1 plus 1 is equal to 2. So 2 would be returned here. So, f of 4 is equal to 2, f of 4 is equal to 2, and this will be returned 1. So 2 plus 1 is equal to 3. Okay, so 3 would be returned here. Okay, so 3 plus 1 is equal to 4. Okay, plus 1 is equal to 4, and 4 would be returned here, and this solution is also returned 1 plus. So sorry, my mistake, f of 1 is also returned 1. So because of that, sorry, by mistake of this, uh, I'm just rewriting again. F of 1 would be returned 1, so 1 plus 1 is equal to 2, so it would be updated by 2. Okay, so it would be updated by 2 by mistake, because the base case is when f of 1, so we will simply return 1, simply return 1. Okay, so 1 plus 1 is equal to 2, and so f of 2 is equal to 2, and 2 plus 1 is equal to 3. Okay, and so 2 plus 1 is equal to 3, so the value would be here is, I hope it would be clear to you. So f of 4 is equal to 3, and 3 plus 1 is equal to 4. So the value here, it would be 4. I hope it would be clear to you. So f of 5 would be equal to 4. So 4 plus 1 is equal to 5. So f of 10 would be equal to 5. So we will simply say that the value of function of 10, f of 10, would be simply return f of 10 is equal to 5. So the minimum number of operation is 5. I hope it would be clear to you that what is that recursion is working is here right now. Okay, so this is our approach. Now how we can implement this, and here is the coding implementation. Okay, so this is that coding implementation. This is our base case when value of n is equal to 1, so we will return simply 1. Okay, if the value is divisible by 2, so we will simply return the 1 with minimum operation of this recursion. Okay, now again, if it is not divisible by 2, so we will simply increment by 1 and decrement the value n by 1. Okay, so here this code is running. this is working fine. Okay, our solution is expected output. Our output is equal to the expected output, and this is the solution of C++. And the same solution you can get this Java. Nothing would be changed. Nothing would be changed. That simple, that base case solution. Okay, I hope it would be clear to you. Please like my video, please subscribe my channel. If you have any doubt, so please comment on my channel. Thank you.